Bismillah ar-Rahman ar-Rahim. Today our lecture will be hepatitis B and D viruses. I am Professor Manal Badur from Microbiology Department. Now, for years I've been quoting Joshua Lederberg, a Nobel scientist, for his saying that the single greatest threat to humans' continued existence on Earth is the virus. For years I've been saying this, but not until this year that we actually experienced this worldwide. You've seen how virus can threaten humans. Hepatitis B is inflammation of the liver. And you've learned that we have several hepatitis viruses that have been named or designated alphabetically according to the order of their discovery. So we will be talking today about hepatitis B. When they first discovered it, they called it serum hepatitis because this virus can be transmitted by serum. بيتنقل بالسيرم من خلال serum. It causes an acute systemic infection, mainly targeting the liver. أهم عضو هو الليفر، هو اللي بيبقى affected بالhepatitis viruses. And this one is caused by hepatitis B virus. Now, a normal liver, after infection by hepatitis B virus, can lead to acute infection, followed by resolution, يخف غالبا. Most probably this is the outcome, as you will learn. Or it can become a chronic liver inflammation with its sequelae, as you will also learn later, from liver cirrhosis or hepatocellular carcinoma. غالبا بيحصل recovery, acute infection و recovery. بس في بعض الحالات بيبقى فيه chronicity والcomplications بتاعتها. The causative agent, as you see here, is hepatitis B virus, and this is the only member, or this is a member of the Hepadna-Viridi viruses. Hepa DNA viruses, the family of Hepadna-Viridi. Keep in mind, all hepatitis viruses are RNA viruses, except for hepatitis B viruses. This is the only one which is DNA. The virion itself, the virus particle, is about 42 nanometers in diameter, and it is enveloped. You can see the envelope in yellow, and we will talk a bit later about this envelope. It has an icosahedral nucleocapsid, cubical nucleocapsid, as you see here, and the genome is partially double-stranded. One of the strands, the minus strand or the negative strand, is not full, it's not complete. For reasons of the virus, you don't have to go into these details. So it's partially double-stranded, and the genome itself is circular, and it's DNA, of course. So this is the virus particle again. You can see the envelope, and the envelope contains an important antigen, which is hepatitis B S antigen, or hepatitis B surface antigen. This is a very important antigen for the virus. The core antigen is called hepatitis B C antigen, and this together forms the capsid of the virus. Another component of the virus, which is not usually assembled with the virus, is hepatitis B E antigen. We will mention a few words about each of these. يبقى عندنا hepatitis B surface antigen، ده مهم جدا، hepatitis B core antigen, and hepatitis B E antigen. You will notice that I have here in this picture, in this cartoon, some extra components. They are not actually components, but they are different formations that are found in patient serum. We will mention this a little bit later, but just remember this. Okay, so now the outer shell or the envelope, like any other viral envelope, is host cell derived. The virus derives it from the host cell, from different areas of the host cell, depending on the type of the virus. For hepatitis B, it acquires this envelope, and this envelope contains the important viral protein and viral antigen, which is hepatitis B surface antigen. So the envelope, or the outer shell, is host cell derived, but it contains a virus antigen, which is hepatitis B surface antigen. In the inner part, we have the nucleocapsid. As we said, this is from the hepatitis B core antigen that encloses the viral genome, the DNA. The virus also contains the enzyme DNA polymerase. Hepatitis B virus contains an enzyme which is the DNA polymerase. This is the enzyme that is needed for viral replication. We also have the hepatitis B E antigen, which is not usually assembled with the virus particle, but it is secreted in a soluble form, and we will learn what this signifies. As we said, if we look at the patient serum, these three forms appear in the patient serum. This is an electron microscopic picture of a hepatitis B patient serum. You will notice that we have the full virus particles. By the way, they were previously, when they were first discovered, they were given the name Dane's particles. So the Dane's particles are the full virus particles with all the components we mentioned previously. كل المكونات، يعني virus particle الكامل كانوا بيسموه Dane's particle. But in patient serum, we notice that the Dane's particles are the minority. مفيش منهم كتير في البيشنت سيرم. الأكثر, the more common, is that we find small spherical particles and larger filamentous particles. The Dane's particle, we said that it has a diameter of 42 nanometers. The small circular particles have a diameter of 22, and the filamentous particles have a diameter of 22 and a length of up to 200 nanometers. What are these spherical and filamentous particles? Actually, they are pure hepatitis B surface antigen. So there is much more hepatitis B surface antigen in the patient serum than is the hepatitis B virus. Why are they present? They are due to overproduction of hepatitis B surface antigen during viral replication. Okay, so this is the Dane particle, the full virus particle, and this is the spherical particle and the filamentous particles, which are found in abundance. Okay? Thank you, and we will continue with another part later.